Well, hello there, AP Physics. I am trying to do my best and get caught up with the videos for your homework, and unfortunately I wasn't thinking and I did not bring my microphone, so I am hopeful that you can hear me all right. I'm going to be looking at momentum number 1 right now, and let's make sure we can actually see what we're doing. Okay, so let's go quickly through these questions. These are all pretty straightforward, and hopefully you will not have any difficulty with them whatsoever. This is a classic conservation of momentum question. Hopefully that question here doesn't really, gosh, you can logic that out pretty quickly. How much chemical energy is converted into mechanical energy in the girl's muscles? All right, remember that primarily we're dealing with kinetic energy here. So once you consider that and the formula for kinetic energy, it is not that tough to figure out exactly what kind of energy she is changing. All right, not so bad. And then C, of course, is looking at why an explosion conserves momentum, which is exactly what this is about. And again, hopefully between your notes and just some plain logic, that shouldn't be too difficult to see. Okay, so then we're going to get a little bit tougher, but not really much. Okay, so you've got these two blocks and they're held together with a spring, and then and a string as well, and then the string is burned or cut, and then the blocks spring apart. Okay, so velocity of mass m. Well, this is a classic conservation of momentum equation. Please watch your directions. Okay, they are assuming, you notice it tells you even right here, right is positive, left is negative. So make sure if you have a velocity to the left that you are labeling it negative, and then you follow the algebra through. That becomes rather important. Okay, part B, find the system's original elastic potential energy. This might seem tricky at first because if you think about elastic potential energy, you might be going, okay, well 1/2 kx squared, and I don't know k, but remember, we're conserving energy as well. This, if we figure that the kinetic energy of each block, block M and block 3M, that'll be the same as the elastic potential energy, and you should be able to find it from there. The nice thing is too, it's also a great reminder that because with kinetic energy we square the velocity, we never have a negative kinetic energy, even if we have a negative velocity. C and D, again, I think fairly straightforward. Okay, number 3. My God, number 3, yep, there we go. All right, so we're looking for force here. This is an impulse problem. We're going to be using, well, I guess technically I'm going for that one, aren't I? All right, but we're looking at Ft equals m delta v, and you should be able to find the value of that force and explain why you should always belt your kid and not hold on to them. That was something we did in the 70s and 80s. I shouldn't say we, I was a child, but my mom didn't have car seats, and it's a wonder we're all alive, is exactly what I'm going to say about that. All right, last one. Number 4, ball of mass, 0.1 kilograms, drop from rest. You get a rebound height. Notice that your drop height and your rebound height are not the same. That's going to tell you that you need to figure out your kinetic energy right before the impact with the floor and the kinetic energy right after the impact with the floor. That's going to help you out. All right, that way you'll be able to do your impulse because, again, you're going to come back to this equation up here, but that change in velocity is going to be important. And remember, with a rebound, that you are changing direction, so be careful with your double negatives, is what I'm saying here, because if you're going to do at final and initial, remember you're subtracting final minus initial, and you're going to end up with a double negative in there somewhere. So be careful with those. You should have actually a very large delta V if you are rebounding. Okay? Now hopefully that helps you out with that first one. Talk to you soon.